All right, problem number one on homework assignment, bonus number one. Given P implies Q, which is true, and then there are all these choices. Now, it's a lot easier for a test or an exam to just memorize that this is equivalent to P implies Q, not Q implies not P. But why? So, given P implies Q, this is basically a logical statement. And, you can look at it as a mathematic thing, but, it's easier, I think, to process it as, English. And we're saying that if my dog is wagging his tail, this is a conditional. If this is happening, then this is happening. So that means that P means that my dog is wagging his tail, and Q means that he's happy. So if this is happening, then this is happening. That is the whole idea of a logical implication. Now, we can have multiple different scenarios, all right? We have a column here for P and a column here for Q, and you can write true or false, or you can write 0 and 1. It doesn't matter. I chose to do 0 and 1. 0 just means that it's false, and 1 means that it's true. So in this first column, or not even the first column, but in this first row where we see, P is 0 and Q is 0, well, that would be equivalent to saying that, if my dog is not wagging his tail, and then he is not happy. But the reality is that whenever we have a 0 here, because we're trying to prove this entire statement here. We're trying to prove that this condition is true. So we kind of have to say that this is vacuously true, because the reality is that if P is 0, then what that means is that my dog is not wagging his tail. But I can't make the assumption then that my dog is not happy. I can't make the assumption that my dog is happy, because this condition is not even true. So what we say is that the overall implication is vacuously true. So this is actually going to be a 1. And same thing here. It doesn't matter if this is a 1 or a 0. We're going to say that it's vacuously true, because anytime that this is false, then we just kind of have to assume that the implication is true. Now, in this case, we have 1 and 0. So that would be equivalent to saying that my dog is wagging his tail, but he's not happy. And then if that's true, that contradicts our whole premise of P implies Q, so therefore it's going to be a 0. But the whole implication of this thing leading to this thing basically is not true according to this truth table. And then, down here we see 1 and 1. That just means that we're basically confirming what we see, our observation. If my dog is wagging his tail, then that means that he is happy. So that's going to be a 1. And that is our truth table for P implies Q, 1, 1, 0, 1. Now, if we wanted to look at not Q implies not P, what we would do is make another column here, and not Q is going to be just the opposite of what we have here. So we have 1, 0, 1, 0. Because this is still Q, this is going to be not Q, the opposite of Q. And then here we have not P, and that is going to be the opposite of what we have on P here, 1, 1, 0, 0. So that'll be 1, 1, 0, 0. And now what we want to look at is the implication of not Q implies not P. So if not Q is true and not P is true, so this would be a 1 because we have not Q is true and not P. Then here we have a 0. So again, when we have our premise, if my dog is wagging his tail, if this first thing is not true, and our implication here, by the way, is not Q implies not P. But we look at our 0 here, and it doesn't really matter what this number is. If this is a false, then this is going to be vacuously true. It's going to be a 1. And then here we have that this is true, but because of that, we know that this is going to be false because we want this to be 1 and 1 in order for the conditional to be true. And then 0 and 0, this is going to be vacuously true again, because whenever this is 0, then this one is going to be a 1. And as you can see, P implies Q has the exact same column here as not P implies not Q, which means that they're logically equivalent. And in the English, context, this is basically saying that my dog is not wagging his tail. This is like saying that my dog is not wagging his tail, right? This is our not Q. Therefore, he's not happy. This is our not P. That's why we have not Q implies not P. But logically, it's the exact same thing as this column right here.